record this. Yes, well, because those that miss the class would have to get it. Okay, please go ahead, Walter.
Okay, sir. Still on this supervised learning.
Yeah.
I want to say this way, the way I capture it in my jotter. Supervised learning is, let's say, has two legs. One leg is data input and output. Then under it, labels. The labels also the labels also have two legs, training and predict under it. So with that, the computer can be able to carry out the information given to it. So I think if that is correct, sir, I don't know the way I see it.
Okay, thank you very much. You're actually on the right path. So I'll just explain again. So these labels here that I put here, this label is telling us that the data we impute to a supervised learning algorithm is labeled. So you're going to label it by saying, okay, these particular features, like you give the model some features for the cat, but you also tell the model that this is a cat. That's why under the labels, you have cats, you have dogs and rats under this label. So we're telling the model that this is a cat, this is a dog, this is a rat, and then the data has some features for each of these models to fit in. So what I'm doing today, actually, let me just clarify. I want to give you a broad picture of what we are going to look at for the entire course. Supervised learning, unsupervised learning, everything. But we'll still go, from next week, we'll still go deeper into supervised learning and look at some examples more. Okay? So this is not the beginning and ending of supervised learning, but just an introduction, right? So the data we give to a supervised learning problem is labeled, and then we train the model on that labeled data, and we're going to, the computer is going to learn from that labeled data to develop some model that it can use to predict anytime it sees another data similar to previous data that it has seen. If we don't give it the label, it just identifies that particular data or particular item as for what it is, like with the right label. Like this example was saying that when the model trains on cats, dogs, and rats, once it sees a rat, because it knows the features of a rat, even if you don't tell the model that this is a rat, it will predict that, okay, this is actually a rat based on what it has seen before, right? Yeah, so I'll just go back quickly to just, because of where we just started recording from, so just to give a brief overview so that other people, when they watch this video, they will get it. So we're talking about artificial intelligence and machine learning. We said artificial intelligence is making computers reason like humans. It's a more general term for computer intelligence. So artificial intelligence can be sometimes just simple decisions. It can be sometimes just simple decisions that we pass to a computer, and the computer can act on that. But machine learning is making the computer have the ability to learn. So the computer sees the data, it's able to learn from the data, and then make intelligent decisions based on that. So we went further to break it down that artificial intelligence can be simple as decision making, image processing, or complex like language understanding. And so went into machine learning also to say that machine learning denotes just making the computer learn by giving it past data, and then the computer is able to learn from past experience to make predictions into the future. So we're now on supervised learning, and now I want to give a problem and say, okay, let's share on some things about I think we can do this as an activity for this class. So let's say we want to build a supervised learning model for a bank credit card fraud detection, right? So the bank wants to be able to, when people, like you are going to pass some data into the supervised learning problem, and then the bank wants to be able to identify when a credit card transaction or a debit card, when a card transaction is a fraud or when it's not a fraud. Or which other example can we use now? Okay, maybe we can also use email spam, right? Let's say emails come into an inbox. The computer is able to identify when when an email is a fraud or is not a fraud. So what kind of features do you think, what kind of data do you think we should pass into a computer to help it identify fraud or not fraud for credit card transaction, debit card transaction, or email spam? Anyone wants to share with us? Just share
Hello,
any
please.
thought. Nothing
I would like
nothing
to
is
talk
right or
about
wrong.
I want to talk
Yeah.
about the email spam.
Okay, please
How a
go ahead.
computer can be able to distinguish between a spam email and
Thank you.
also a real one.
Yeah,
When okay, you can feed into the computer emails that contain something like promotion, something that is telling you that
exactly.
you've won a particular jackpot, or something that contains maybe a prize and things like that. And also, it is show. I mean, the programmer will have to show the computer or the
Mm-hmm.
model original emails, and then
Exactly.
from those label of both spam and original, a lot of
Yeah.
them, then the
Yeah.
model will be able to learn. And then when
Yeah.
it sees something that looks like a spam, it will be able to categorize that in a separate box. So, and I think that is what Google use for Gmail, because you can see
Exactly.
a lot of emails that contain somewhere else. Yeah.
Yeah, thank you very much. Clear example. So Gmail uses it to classify promotions. You see an inbox for promotions or spam. Then the normal email would be on the main inbox. I think Yahoo also does that. Yahoo Mail also has spam email. Then so there's the model has to be fit with good original emails, good emails. Then it has to also see promotion emails. So it's able to, when you train the model with different promotion and non-promotion emails or good emails and all that, then the model is able to identify that difference going forward. Any other person wants to share on this supervised learning?
Hello.
Yes.
Okay. Yes,
Yes.
this email something. Then okay, the email that I'm thinking of, this HTTPS. I don't know the
Yes. Okay.
hypertext. If it does not have S, we have
HTTP. Yeah.
HTTPS.
Yeah.
If it does not have S, then you can categorize them as spam email. Then that means they are not coming from a
Mm-hmm.
secure source. So something like
Yeah.
that.
Yeah, thank you very much. So you see, one thing that we're learning from this also is that the more features you have, the better the computer is able to predict. Because this thing that we're looking at here said supervised learning, data input. If you just put some few features, data into the model may not learn very well. It may not be, even if you may give it rat and just say, oh, this rat looks like a dog. Because it only knows that, okay, maybe it only identifies with the mouth or ears and eyes. Rat has two eyes, dog has two eyes. It has 2 ears, dog has 2 ears. So the computer may just learn just a few features and then it predicts randomly. So one key thing that we're learning from this now, this exercise, is that data is very important when you want the machine to learn. How you classify your data, how you put the features for your data, it is very important. Because when you're going to start getting your data for your project, you are going to want to get enough data so that your model can predict well. So because if your model is not predicting well, then it's not going to be useful in production, for actual businesses, right? So data is a very key thing. Someone else wanting to comment on this?
Yeah,
Yeah.
I want to comment and also have a question.
Okay, please go ahead.
Just as you said, my own comment is just that during the labeling, there are keywords that you look out. That
Exactly.
you, when you are trying to bring out email, you look at fraudulent email. There are keywords that will make you to know that okay, these are fraudulent email.
Yeah.
So maybe, yeah, a lot of emails are always starting with can you, that is sent to you, all about money, a lot of them.
Money,
Invest
yeah.
in this and that and that and that. So
Mhm.
from my own understanding, that is what, based on what you have just explained, that's what I can
Exactly.
try. So
Yeah, yeah.
my
Yeah, the
question now,
question.
yes. So my question now is, I want to just get a difference between this supervised learning and me creating a function, like let's
Mhm.
say a quadratic equation. I'm just giving you,
Good.
yes, I have a function which I give it an input. There's a
Mhm.
function already, and then
Yes.
whenever I give it that this is a, x equals to a equals to this, b equals to this, C equals to this, it should always give
Mhm.
me an answer. And
Yeah.
then this model also, so, or maybe I have y equals to x, mx plus c. So whenever
Mhm.
I have my x and then I have my c and m, I should be able to have a y. So what
Okay.
is the difference between a function
And
and this
okay.
thing? So that's the question I have. Thank you, sir.
Okay. Yeah, thank you. Very good question, actually. Um, let me see. Okay. Let me see. Okay, I think I can do this. Let me just. Okay, so I think you have y equals to mx plus c. Is that what you said? Right? Something like this.
Yes, sir.
Barnabas,
Yes,
are you
sir. Yes,
there?
sir.
Okay,
Yes, sir.
so let's say we have m equals let's say we have m equals 2, then c equals 3. So if you have y equals 2x plus 3, let's say if x is equal to 1, y is equal to 5, right? If x is equal to, let's say 2, y is equal to 7. If x is, let's just do the 3. If x is equal to 3, y is equal to 9, right? So this function, right? This is a function. If you give it any x, it knows what the y is. So this is a simple function, right? Simple.
Yes,
Now,
sir. Yes, sir.
what supervised learning is that it doesn't know the function. Like let's say you just have some x and y, and let's say this y equal ms plus c is simple. But if y equals, let's say y equals sine x, cos x, mx cube, you may not know, but you have several x and y. I hope everybody can follow. We're just this. I hope this is not too complex. Let's say you have 1, you have 5, you have 2, you have 7, you have 3, then you have 9. So the difference between you having a function and what machine learning does is that when machine learning, you give machine learning the x and the y. So let's do some exercise here and ask everyone, what does x mean in this machine learning we've talked about? What is x here? What would x be in a supervised learning problem?
Why?
Yeah? No, what would x in this? Okay, let me
It will,
explain.
Input.
it
X
will be
is
an
input.
input.
Exactly,
Input.
exactly. Yes, yeah, that's what I'm trying to get.
Input.
X is the input. So X is the input. Then Y is the output, right? So the machine learning will look and say, okay, it looks like anytime I see 1, I get 5. Anytime I see 2, I get 7. Anytime I see 3, I get 9. So this machine learning model will now learn this Y equals 2x plus 3. So we're trying to find the relationship between the input and the output in machine learning, in supervised learning, especially when this input function is very complex, right? Because it's not as easy to know that the relationship between a cat whisk length or ear size or tail length and leg and all that. It's not easy to know what y would be when you have s cube, different x's. The different x's now can be the different features of the input. Okay. Don't worry about the maths. Don't worry much about the maths. But that's a very good question. That's a very good question. Okay, so the idea is if you have a simple function, the idea is if you have a simple relationship between the data input and the output, you can just use some simple functions to solve that. Maybe if it's quadratic equation, you have a simple quadratic formula. So that's it, right? But when it is very complex, and let's say y equals 2x squared plus 10 exponential x plus y exponential or something like that, then you will need machine learning to help you learn it, right? So it's going to learn that relationship, and anytime you give it another x, it will use that relationship that it has learned to predict an output. I hope that is clear.
Okay.
All right, sir. So if I can get you clear,
Yes,
you
please
are
go ahead.
yes, you are telling me, you are saying that a function, you have to create a model yourself, which is like the function. So whenever you give it an input, it uses that function to give you an output. But in supervised learning, the function, which is the model, is not
It's
known.
not known.
So you now give it input and output for the machines to be able to create a model so that it can use it to predict other functions. Am I right?
Exactly. Yes,
Okay,
perfect.
sir.
You
All
got
right.
it. You got
Okay,
it.
thank you.
Yeah.
Thank you so much.
Yeah.
I really appreciate it. Thank you.
Yeah. So this is what we're trying to learn. In machine learning, we're trying to learn the model, the function. We're trying to learn the function. We're trying to learn the model. So once it learns it, very powerful. Once it learns it, it can start doing magic for you, right? So that's supervised learning.
And Israel.
Yeah, please go ahead.
Yeah. Okay. You gave all the tasks the other time, and I want to attempt it, like how to
Oh,
use
good.
machine
Please go ahead.
learning
Yeah.
to unravel fraud.
Yeah.
So, and I think some of the things that the machine learning model will look out for
Mm-hmm.
is how I mean the number of how much time it takes a person to key in the password. That could be one of the features
Okay.
that you want to
Okay.
look at, especially when you're using a card to make transaction, whether online or somewhere else.
Yeah.
And also the number of times the person entered password incorrectly. That could also
Yes.
be a thing to look out for.
Exactly.
Also, the
Exactly.
frequency of usage of that particular card. Maybe you've used it yesterday, you're using it today, and the machine learning understands that the owner does not, maybe the owner withdraws once in a week or once in a month.
Yes.
When you're
Yes.
coming twice, 3 times in a day, then it will raise an alarm. And
Very
lastly, one
true.
thing I also think about is the amount. Maybe usually the person doesn't withdraw anything above 500 euros, and
Yeah.
then want to use the card to withdraw 2,000. So that could create an alert by the machine.
Very correct. Very correct. Thank you. Very correct. Like, um, yeah, I think there was one. Is this Shaquille O'Neal, one great basketballer, right? He went to a store to buy stuff, Walmart store. So he wanted to buy a lot. I've forgotten how much he was buying that. They made almost $1 million or something very high. And then when they swiped the card did not go through. He said, he has that money. They swipe the card. They swipe and the card did not go through. So then he got a call from his bank, and the bank was saying, it's like someone wants to do a very high transaction on your account. And he said, no, that's me, right? So the bank had a system that helped them block that transaction because it was an irregular transaction. It looked like a fraud, right? So that's a very good example what you just said. So some banks have that system of alert where for me, like sometimes when I'm paying a website, I don't pay something off, my bank would just block my card, or they would send me a better way to do it now. They would send me a text to say, okay, are you the person doing this transaction? Can you say yes or no? Right. So those kind of things are machine learning, right? So it learns different features. Thank you. So we can still give some examples. Anyone wants to share? Okay, the other thing I wanted to ask is, let's think about healthcare. Now we're talking about input, model, then output, right? So let's think about an application in healthcare, for example. Though I've given some, but if you can think of more, what are some applications that, okay, looks like machine learning may be able to solve this help healthcare identify something quickly and just explain your thoughts around it. Yeah, anyone wants to share? Supervised learning.
All right. I just have a simple example. Healthcare, like let's take an example of a chicken pox. Chicken pox as an example.
Good,
So
good.
we have people having chicken pox. We see them having the features that we can derive out from their rashes on their body, their high temperature,
Great.
then complaining of maybe headache and fever, and those are the things that we can have as a future. Or
Great.
that is if they are to label. So then we can be able to label people that, okay, if you have this kind of this thing, then you are likely to have chicken pox. So
Great.
we can use that to label and then create a model that can predict.
Thank you very much. Perfect. So we're talking about that disease detection. So disease detection you can use supervised learning for it, where you feed data into the computer. Your data now is the symptoms of a particular disease and the label for that disease. So it's saying if a person has rashes on their body and the boils are very big, and the person has high temperature, the person has low diet, low appetite and all that. So those features can help the machine learning detect, okay, it looks like this person has chicken pox or doesn't have chicken pox. So early detection of disease can be very, supervised learning can be very useful for that. Okay. Any questions? Anyone that's not following, please, you can feel free to ask any question. Okay. Okay, we'll dwell more on supervised learning in the next class, and then we'll build some models. Maybe in the next 2-3 weeks, we'll build some models with some data in subsequent weeks. So today we're just doing introduction. Let's now go to unsupervised learning before we go into some Python. So for unsupervised learning, right? For unsupervised learning, we are looking at the input of the raw data is unlabeled. So you see it here that there's no label for the data. So it's expected that the computer would give some interpretation to this data, and then it will be able to classify stuff that look similar. So like if you look at this model now, this picture here, it looks like the computer is able to identify that all of these pepper, they look similar. Then this other, I don't know what they call this fruit now. Then the onion, right? All of these look similar, right? So for example, if you are going to use unsupervised learning to solve the problem of which one did we do just now? Let's say the credit card fraud or something. If you're going to use supervised learning to solve that, you are going to send some features of the card and say, okay, the amount of the transaction, the frequency of the transaction, the limit of the card, different things that you can put on the features. And then you will label the data to say, okay, this is a fraud or this is not a fraud. So that's supervised learning. But when it's unsupervised learning, you just pass a bunch of transactions into the computer, and then the computer is going to learn some transactions that are different from others. Maybe, like you said just now, maybe transactions that are very high. It says, this does not look like normal transactions within this group. So we can say when we break the data into different parts, we have some transactions that are okay and transactions that are not okay. So we will now let the computer know, okay, when you flag a transaction in this, let's say Pepper group is irregular transaction. Say when you flag a transaction in Pepper group, raise this alert, right? So you see that some problems can be modeled as both supervised or unsupervised learning ahead. So, but there are some specific problems that you can only do with supervised learning because you have the data, you have the labels. Why there are some problems that you can only do with unsupervised because you don't have the labels, you don't have enough data for it, so you just use unsupervised learning. So unsupervised learning, the major difference between it and supervised learning is that supervised learning, you have the labels. It's the same input and output. But unsupervised, you do not have the labels. So you want the computer to just learn the differences. You just learn the differences. It's going to look for similarities between a particular group and then put them in different groups together. So when we're doing this, you would see how it is. We'll do some examples with Python. Yeah, so is this clear? Can someone explain to us what unsupervised learning is? Let me be sure that you got it. Can someone just give us, yeah.
Based on what you have just explained now,
Okay.
what I can deduce in this is when you are dealing with unsupervised learning, one key thing is there's no labeling. That's
Yes.
that's not labeled. So I immediately when you were explaining, my mind just went direct to an example, like what we had in 2019. We had a coronavirus, which which was under a case study trying to know the symptoms or some distance. So maybe in that case, unsupervised learning, where futures are not readily available for us, for us to use to label. So
Yes.
we can decide to give that, okay, this is it. So for the computer to be able to what to learn and bring out some features by itself and then develop a model for us. So maybe example of a cat and a dog, for the computer to be able to know that, okay, a cat is having a smaller tail, a dog is
Yeah.
having a longer tail, a cat is having longer ears, dog longer ears, dogs are bigger in size. So
Yeah.
for the computer to be able to learn and map this by itself, and then it should be able to give us the analysis. So that's what I can understand from what you just said.
Yeah, thank you very much. That's very good to give good details also. Like the coronavirus, you said, we can look at symptoms within people and or maybe it can even be through images. Say, okay, the image of a blood screen, you check and the computer scans it and it's able to show that, okay, this other group looks like an outlier and this person probably has COVID. It doesn't look like what we've seen before. And so unsupervised learning can help in situations where there are new things that we do not know before or the computer has not seen before. I think I want to also get a lady to comment on this. It looks like only guys are talking, but there are other ladies. There are ladies in the group. Please, can you share on unsupervised learning? Your understanding. There's no right or wrong answer. We're all here to learn. Just let us know to ensure that you're following.
Hello, I don't really understand that much, but what I understand is that according to unsupervised learning, it said there's going to be unlabeled data. So the computer itself, we categorize those items that are similar, and also we differentiate those items that are different.
Very good. So you see, you say you didn't know anything, but you're now using the right words. So that's very good, right? So you said something that about similar. So the computer is going to categorize things that are similar, and then the other ones that are, it's going to just categorize them based on similarities. So when we go into unsupervised learning, we're going to get things like similarity distance. So the computer is able to check, okay, what's the difference between onion and pepper? It checks maybe it checks the difference between onion and pepper. It says, this thing looks like the difference is 5. It checks difference between this and this. This difference looks like it's 10. But if you check difference between this and you say this looks like 1. Okay, the computer goes to the next one and sees, okay, maybe this one it sees 1. Then this and this, it sees the difference is just 1. It looks at onion and onion, see the difference is just even 0, it's just the same thing. Then looks at this and say our difference is just 0. So all these ones that have small differences is going to just categorize all of them together and say, no, these ones are very small difference. So this is a similar group. This pepper, just one difference between this and this, just one. So this will be in a similar group. Then this other one too, it checks and see, oh, this is different, 0, 0. Just say, this is in a similar group. So that's how we just categorize everything. So you have just helped us, you just used the right term for us, similarities. So the computer is going to be measuring similarities to know those differences, to categorize the different groups in their proper place. Okay. So any questions so far? Because we're rounding up this part. Any questions so far? Okay, I think it's clear. So we'll go to the final. Yes, please go ahead.
Yes, from my understanding, it's like the major difference between supervised learning and non-supervised learning is that the input data is labeled for supervised learning, and for unsupervised learning, the input data is not labeled.
Yes, yes, exactly. Okay. So that's a major difference. Though the models are different, yeah, but a major difference is that you have labeled data for supervised learning and unlabeled data for unsupervised learning.
Thank you.
Okay, thank you. Any other question? Okay, this is the last slide for this. Yes, please go ahead. Yes.
For the unsupervised learning now.
Yeah.
You know, the inputs are unlabeled.
Yes.
Now, is it that one is going to, like from your slide now?
Yeah.
Need algorithm to separate pictures of different groups.
Yeah. Sorry, sir.
I said from your slide.
Yes.
An algorithm to categorize and separate those inputs
to different groups. Yes.
To different groups.
Yes.
Yes. For supervised learning now, you're going to get the inputs and outputs, and then the computer forms the model.
Exactly. Exactly. So thank you very much for that. Are you done with the question? Okay. So what happens here for unsupervised learning is that the computer is forming a model that tells you the relationship between the data inputs. Let me see the person. Okay. So the computer is learning a model that tells you the relationship between the data input and the output. So when you give it a particular input, it's going to learn that use that input features that you give it to predict an output based on the to predict an output as one of the labels that you give to it, right? Now, for unsupervised learning, it's also learning a model, right? Because the model is going to learn the relationship between all of these items here, and it's able to predict and say, okay, this particular item is in this particular group or this group or this group. It's just the output for the unsupervised and supervised learning is different also. The output for the unsupervised learning is usually categorizing different items into different, usually finding the similarities between items and differences so that you can put them into different categories, right? Why for the supervised learning, it is trying to predict the labels that you've given to it. So it's trying to predict the labels that you've given to it. So supervised learning, you have the labels, it learns the relationship, a model, and it predicts an output. So unsupervised learning, it also learns relationship, but it's just creating similarities. It's just creating similarities and separating the different inputs into different groups. So is that clear?
Very clear.
Okay. Thank you. Any other questions?
Hello.
Yes, please go ahead.
Yeah, so for this unsupervised learning, can you hear me?
Yes, I can. Please go ahead.
So how does it compare data? Let's say, for instance, you give it apple and I want to put it in value. Let's say it want to compare value. Let's say in size now, and you have two different objects having almost similar sizes.
Okay.
So how does it compare between the two and detect that, okay, this is different from this? Like, plantain and banana.
Yes, exactly.
Yeah, so when you have a small plantain, like an unripe plantain, and those kind of big banana, they look completely similar.
Yeah.
How does it compare between those two and detect the differences?
Yes, very good question. So you see that like plantain and banana are very similar, right? So like what we said just now, it's the way you structure your data and the amount of data you give to the computer will determine what the computer can learn, right? So data is very important, and the features that you get from that data will help the machine differentiate or learn things from that data. Like if you look at this example now, you will see that the machine is not fully able to differentiate between these peppers because they are similar. But this is green pepper and this is red pepper. So it's except you now also include the color as a difference, as a feature. Then when the machine measures that and see like, okay, it looks like this color is different, then it can also maybe have another group for this. But that also depends on whether you tell it to have 4 groups or 3 groups or 5 groups and all that. So we're going to get into that when we are modeling. But to answer your question, the most important thing is what you are giving to the machine. Your data should be very clear. That's why we have things like, we're going to come into this feature engineering. There's something we call feature engineering, right? So feature engineering, you're trying to create features that would improve the computer's understanding of your data and be able to improve the predictive abilities of your model. So feature engineering would help you, like banana, you can say, oh, the weights can be a difference. Banana and plantain, the weights, because plantain is usually bigger, can say, oh, the stem for plantain is longer, or this. So you can create more features that would help the computer be able to know those differences. Okay, is that clear?
Yes.
Yeah, very good question. Any other question? Yes,
Hello,
please
sir.
go ahead. Yes, go ahead.
Sorry, in order to understand this better, like the way you explained it while we're doing supervised learning, you were able to bring up practical examples like email, like medical stuff. Is it possible we have unsupervised learning under that kind of situation, or that kind of example, such that we would use those kind of same data to operate under unsupervised learning?
Yes. So like what we said now, it's there are some problems that can be modeled as supervised or unsupervised learning, right? Like even the example we used here for the example we used here for the animals, these cats and all. Let's say the computer does not know, when we feed to the computer does not know this cat. It doesn't know if this is a cat. It doesn't know if this is a dog. The computer doesn't know if this is a rat, right? So if you don't have labels, then you need to use unsupervised learning. So the computer is going to look at all this and be able to say, okay, it looks like these animals that look like this, they are in one category. It doesn't know the name for them. That's another thing about supervised. It doesn't know the name, but it just gives like, okay, this is one category. Let's say C1. It just looks at this and say this is C2. Then you say this is C3. The computer doesn't know the name for all this because you didn't give the computer a label. But it measures the distance and knows, okay, these things look similar, so I'm going to put them in one group. So when you give it a rat, for example, it's just going to categorize the rat as that group C3. If you give it a dog, it categorizes it as that group C2. So it doesn't know the difference between these groups, right? Just like we see here. The computer doesn't know if this is eggplant or if this is an onion or if this is pepper. It just knows that these things, they look similar based on the data that I have here, right? So also, let's think of one other example of let's take another example of an unsupervised learning problem, like a business case, because I was going to come to this. Like if you look at, let's just say, okay, Twitter, for example. I don't know how many people use Twitter here, but you know, like Twitter has a column for, they call it for you, right? For you. Then they have following also, something like this. So if you click on for you, Twitter is going to recommend tweets that are for you. So based on how you interact with tweets, Twitter is going to recommend, or even Facebook does it too. Facebook is going to be recommending on your page posts that you will like. So what they are doing there is an unsupervised learning where they are looking for tweets that are similar to the kind of tweets you like. Similarity again, right? So they are going to look for tweets that are similar, and then they'll be recommending it for you like that. So you just be, so that to keep you on the platform, let's see the chat. Okay. So to keep you on the platform, they will just be giving you tweets that are similar. So they don't necessarily have a label for those things, but they look at similarity, distances, similarity, and then they use that to give you, recommendations. Okay. Sorry, any more questions? Is it clear? Yeah, is it clear?
Yeah, it's clear, but I have one more question.
Okay, please go ahead.
So for the categories that the model is able to come up with, is it necessary that a programmer will have to go there and label them, since maybe the big data might be very difficult to handle, but now that we have few categories, is there a need for somebody to still go and physically label those ones?
Okay, good question. Like so this is like I think I worked on one project one time where in healthcare actually. So in healthcare, yeah, so they were looking at, so people come to the store, the pharmacy to buy drugs. They're diabetes patients, so they have subscription of insulin or something. They take it regularly and they come to that particular store to get their medications, their prescriptions. But sometimes the managers notice that some people just leave their store and they go to another store to get their medications. So they have the data for all these people. So they're trying to understand, okay, what makes some people leave our store? What is that similarity between the kind of people that leave, right? So what we're going to be doing with that kind of data, what we're doing, though we're trying to use supervised learning approach, but one other approach we're thinking of is you can find the similarities within the data, the people you have. Let's say, this is just for example sake now, let's use one. Let's say this group of people, the data finds that these people are above 80 and a lot of them leave the company. These people are below 60. Maybe only about 50% of them leave. Then maybe these people are below 30 and a lot of them stay with the company. So the thing is, what's happening here is we have been able to break the group into different groups. So unsupervised learning, usually you will now do what we call post-processing. So you can now go into the data and start analyzing to find, okay, what is the similarity that the computer is seeing here? What is that similarity that's making the computer say, oh, this group, this is one group, this is the second group, so this is a third group. So once you go into that group and start finding what the computer is seeing, then you will start to get interpretations for it. You will now start to analyze data and get insights about your data more, right? So it's not automatic, like it's not every project though that someone has to go there and analyze each of the data, right? But many times to make sense of what the model is telling you, you may need to do a post-processing. You go to the data and you start analyzing each of the groups to understand better what is within that group in your data. Depending on so it also depends on the business use case, right? It depends on what the business wants. Like that example of healthcare I said, they will have to go into each of the group and understand, okay, it looks like people above 80. Well, they can decide like, oh, maybe these people, they are dying a lot or something. That's why they leave our company. Then this other group may say, oh, it looks like these people are going to a particular store. Maybe that store, they are not having a good customer service or something, or inventory. That's why people leave. So you now go into the data more and mine it and understand it better. But you needed the machine learning model to help you get from year to year first. Is that point clear?
Okay.
Yes.
Okay, sorry, can I ask something? Okay.
Yes.
About you just said something right now that I think, like in retention rate in a company. So which means we can use unsupervised learning to know why employees are leaving.
Yes.
Reasons why they're leaving. That will help know, okay, this is the reason why they're leaving. Maybe they're not satisfied or more money or something. That could be used with unsupervised learning.
Very good use case. Yes, very good use case too. Very good use case. So once you have the data for the employees, once you pass the data to the model, and the model just classifies them into like, so one thing about unsupervised learning, usually you would have to specify the number of groups, usually, but some models can learn the number of groups. Right? So if you specify, you say you want to check what are the 5 groups or what are the 3 groups within this employee group. You'll be surprised that the model will learn the kind of employees that leave. It will group them into one, depending on the feature you give to it though, right? It will know the kind of employees that leave. Then it will know the kind of employees that stay. For example, where this may not be the case for you, but let's say it may say, oh, it looks like some people, the people that earn 100K, maybe they leave to companies where they start earning 150K. Okay, maybe they've stayed 1 year, they've gotten enough skill, and now they are leaving to where they will pay them more because they have gotten enough skill. So maybe we should start reviewing salaries after first year of staying with us. That may be something that the model will help you learn. Then you can say, oh, people that stay, it's like, okay, one group of people that stays like, they are earning well and they've been with the company for years, so they are very loyal. Maybe they have some partnership, or they have shares in the company. That's what inspires them to stay. Okay, so you are learning more about it. But there's another group that stays, but they earn 100K fine, or they earn 200K, whatever, but they are not really that skillful. They're not really that important to the company. So maybe this group of people is because they are not really valuable in the market. People are not, they're not seeing opportunities to leave. That's why they won't stay anyway. So you now say, okay, this group of people, let's find a way to upskill them within the company. People are, so it's just something that machine learning can help you do. So that's a very, very good use case. Yeah, very good use case. Yeah. Any other person wants? Yeah, thank you. Any other person wants to say something? Okay. So let's go quickly to the use case. So these are examples of business use cases. I know I didn't mention how long this class should take, but usually we try to do 2 hours, but we'll do between 1 hour 30 minutes to 2 hours. Usually we'll try to do 2 hours so we can cover as much as we can within the 3 months that we have. Then I'm going to share some things with you after this, how we can. Okay, so business use cases. So like in the advertising industry, there's a lot of machine learning going on there. There's a lot of it, a lot. So YouTube will look at what kind of videos you watch. So they look at all the video series you are watching, and then they recommend ads for you based on what you are watching, because they now know your interest, right? So if you are watching, let's say football matches, for example, then they will now start recommending for you jersey or football tickets or something like that. If you are watching music a lot, sometimes even the video, the things that the musician wears in the video, they may advertise fashion for you based on that, right? So a lot of machine learning goes on in the advertising industry. Then Google also, like Google, the Google question part, like when you ask Google a question, right? Machine learning helps the machine understand the text first, and then it also recommends websites that have text similar to what you're asking, and it does that in real time, really fast. So machine learning, we already talked about Twitter uses machine learning also. Then this one, ChatGPT, a new kid in the block. Like, it's been a very transformational thing that just happened recently, where ChatGPT, you can ask a question and it just answers you. Let's just do a small. I'm not sure I can share my. Okay. Maybe some other time we can just, when I'm sharing the Python, this I'll go there. So we'll just look at how ChatGPT works, right? I think many of you already know it. You just ask it a question and it answers you real time. So ChatGPT is a kind of machine learning app known as natural language processing. Right? So natural language processing uses machine learning. Then we talked about some healthcare examples, and there's also supply chain optimization, which uses machine learning. So that's where we'll wrap up the presentation today. We'll just go into Python, because some of these models that we're going to be building, we're going to use Python for building it, right? We're going to use Python. So I want everyone to get a basic understanding of Python today. Then you'll take it as assignment, right? You would go through the Python, just give you the basics of it. Then I'll pass the notebook to you. You can go through the notebook, try to run it on your own. Then just understand all the concepts, all the things that I explained about Python on that notebook. Then we'll take it up from there. We'll take it up from there in the next class. So we'll go into Python. Any questions? Any question now? Okay, so we'll talk about the business use cases. We'll go, so I'll give you this article, this link. Just go and read this link to just get some brief overview of artificial intelligence. And then you are going to now give 3 clear examples of business use cases where artificial intelligence or machine learning can be applied. We've talked about so many today. You just think up more and then write it down, and yeah, I'll send out a way to submit the assignment. Yeah. Okay, so that's where we're going to wrap up for this presentation. So I'll yes, please go ahead.
Please help us put it in the chat room, that link, the number 2. This artificial intelligence and machine learning.
Yeah.
It's like machine learning, to my understanding, I don't know if I'm wrong, is the engine room of artificial intelligence. Am I correct?
Yeah, it looks like, yeah, you're correct. That machine learning is like a major part of artificial intelligence, right?
Because like what all that we have been talking about is about machine learning.
Yeah. Okay. So like what I said in the beginning of the class, let me just go back there again. Right. So the course is artificial intelligence and machine learning, right? But machine learning is a major part of artificial intelligence. But because this is a beginner class, we're just starting, we're going to focus more on machine learning and not necessarily do all of artificial intelligence, because artificial intelligence can involve things like building a robot, right? This is artificial intelligence. Like, like Google, not Google now, Tesla cars that drive themselves. That's like artificial intelligence. There may be some machine learning in that, but all of it is not machine learning, right? Okay. So artificial intelligence, it's much more than machine learning, of course, but machine learning is a core part of it. So we're going to focus more on machine learning in this cohort, in this class, because once you learn machine learning, you can apply in 90% of the place where they're discussing artificial intelligence or machine learning. You can apply most of the knowledge you will learn here, anywhere in the world, right? But artificial intelligence can involve some of I think the electrical engineers in class, some of electrical engineering where they are building
circuit.
Yeah, circuit.
Where
they are building IoT, Internet of Things. So Internet of Things, you are trying to connect, for example, connect your fridge to your phone. That's artificial intelligence because you are making the machine, your phone, be able to turn on or turn off your fridge or your heater, those kind of things. Those are artificial intelligence stuff, but we're not going into all of that IoT stuff. We're just mainly focusing on this core part, which is machine learning.
Thank you.
Yeah, okay. Okay, yeah, then, Echo, please. I can see your hand raised. Go ahead. Yeah. Then, okay, Echo, are you saying something? Yeah, good one. Yeah, please go ahead.
Okay. Yeah, I want to get the clarification because my own understanding of machine learning, it needs a lot of data computation and which requires data analysis. So would we do a brief on data analysis, at least just to get a quick review and understanding on how to actually do data analysis? Yeah, because we need this understanding to learn our machine, whether the supervised or unsupervised learning. We need this understanding. So I think we need like maybe 1 or 2 weeks to understand data analysis and data science before we can be able to
okay.
Know the
Yeah. So you're very correct. Like I'll just let me see now. So I'll just go through I'll go to the curriculum. Let me just show you the course outline. I'll go there in a bit. Let me see. So we're going to do exploratory data analysis. Let me stop sharing my screen now. I'll share again the let me see. Okay, let me just share the full screen. Okay, so can you see my screen now? Yeah, you can see my screen, right? Okay. So there's a full course outline here.
It's blank.
Yeah? Can you see the screen now?
Okay. Yes.
Okay. So there's a full course outline here. So what we've touched on today is the basic introduction. We've actually touched some of the things for just this introduction, right? Touched some of the things for the second week. But what we'll do now is what I wanted to share is the Python basics. So for the Python, which I'll open the notebook shortly, we'll do some exploratory data analysis. But next week, when we go into supervised learning proper, we'll still do some exploratory data analysis, business understanding, feature engineering, right? So there'll still be some more data stuff like you requested. So I'm still going to do some more data analytics, right? Because like we said, data is an important part of building your model. You have to understand your data. So we'll do that. We'll still talk more about feature, still data stuff in when we go into classification models, still supervised learning. Then these are all your assignments. Then we'll do unsupervised learning. But along as we're going to be doing the capstone projects. So I'll share more on this just before we close the class today about your capstone projects. And we're going to discuss about how we'll go about that. Okay. So yeah, that's it. So we'll definitely do exploratory data analysis in Python. Okay. Yeah. Any other thing? Is that clear? Then
Yes,
is that clear? Okay, sure. This I don't like this thing. Okay. All right. So now we're going to Python. So so we're going to use Python for the data analysis. So I need to be sure that everyone understands how to use Python before we go into the data analysis proper. So this is an introductory notebook to Python basics. I would send the notebook to you. Then you would download this notebook and run it. So you can just simply go into Colab. This is Colab. Let me see, colab.google.research.com, I think. So let's see that. Okay, I think it's colab.google.com. Let me check. Oh. I want to be sure the website too. So, okay, colab.research. So it has to be HTTPS or colab.google. Okay, so if you go to Colab on Google, you can open this on your phone or your laptop, anywhere. Just go to this website, put your HTTPS there. Let me drop it on the charts. So you can go to that, or for those on their laptop, you can also use something like this, Visual Studio. I think what we'll do is maybe we should check for a YouTube. Maybe we'll share a YouTube link for those that have laptops to how to download. You can download Anaconda. Download Anaconda, then install it. I already have it on my system. So if you download Anaconda and install, we may, maybe during the mentorship session, we may help some people install it if you have some challenge with that. But easy access, let's just go with a Colab for now. Anyone has a question? Okay, I'll delete that person. Okay, anyone has a question on Colab?
You don't have, I have VS Code. Can I use it?
Yes. So if you have VS Code, if you already know how to use Python, you can use that. So VS Code can also open the notebook, right? So maybe I should share the notebook on WhatsApp, or let me see if I can share it here.
Please share it on WhatsApp, please.
On WhatsApp,
I think that would be better.
On WhatsApp? Oh, let me see if I can share. Okay, let me share it on WhatsApp. Just who is admit me into the training room? Hope you got some. Okay, so I want to share this document. Let me see, entity introduction to pandas. Okay, so I'll put the notebook there on. Okay. Okay, so I'll put the notebook there on WhatsApp. So when you open Colab, you would see a place to check file, then upload notebook. So if you upload the notebook, then you can go to that particular notebook and this will come up on your screen. So if you don't have laptop, you can use Colab. Colab, go to that link. Yeah, good. Use Colab.
I want to also you know, some of us will have at least a basic understanding of Python. That's some people. Yeah. So I want to maybe you should recommend some libraries. You know, there's difference in knowing Python functions and then other libraries that we are going to encounter. Maybe like example, I'm doing pandas, I'm using NumPy. So I want you to recommend some libraries so that we can also on our own we can be learning so that when we come it will be easy for us also when you are teaching. So some libraries that you know that are very key. If we start the class, we are likely going to be using them. So,
okay, don't worry, I'll give you libraries.
Hello, sir.
Yeah, I'll give you library. I'll drop a link, then you can go through. You can just go through a particular project. Just go through a project and see what's there, right? Then when you go through the project, you will see a lot of libraries. So, yes, Benga, please go ahead.
Yeah, sorry, please. I am actually new on this, and I don't have any pre-knowledge of this Python thing and all that. But it seems I don't know, but it seems some people are already there because I really don't get what you are talking about or the Colab or the Python, what you are trying to achieve or what you actually want us to do with those things. So I'm beginning to be confused.
Oh. Sorry, did you start the class with us?
Yes, I did. Today, yes, I did.
Okay. So what we said from the slide is that we're going to build models, but those models, to build it on the computer or the laptop or whatever, you're going to use Python. So it's Python that we're going to use to build the models. So I want to be sure that everyone understands Python. So I want to introduce Python now. Because you're going to use Python to code. Is it clear?
Hello. If you can assume that not everyone understands Python, I think that would be a lot of good.
Yeah.
Not everyone does.
Yeah.
Everyone actually.
No. So that's what I'm starting with this, right? I don't know, like we're starting very basic. So we know that sorry, 1 minute, please. Just 1 minute. Okay. Okay, I'm just replying someone on the group. Okay, so let's start again. Like what we're doing now is we're going to build models with Python. So Python, we're starting from scratch. So that's why you see the notebook is called Introduction to Python. So I've not built any model, we're not building any machine learning, we're just starting from scratch. So because I know some people may not have laptops, that's why we're using Colab. This is a Google platform for running Python notebooks. Okay, so if you go to Colab on your phone, I can't share my phone screen now. So if you go to Colab on your phone, just go to colab.research.google.com. I shared the link on the chat. If you go there, Google will open a page for you. So you can click on new notebook or upload. If you click on upload, then anywhere where you downloaded that notebook that I just sent on the chat, that notebook I just shared on the chat, right? If you upload it, then you will see this. Is there anyone there? Omotayo, Wonye, are you there? Abdul, are you there?
We're here.
I'm there already.
Okay, you already uploaded the notebook now.
Yes, I've uploaded it.
Okay, perfect. So with this notebook now, you will see that we're going to just introduce Python. So it's just an introduction to Python, right? So first simple operation we can do in Python is, I don't know if we should import these pandas, but let's do like this. Okay. So if you want to work in Python, right? Let's see the first cell. We call this a cell. The first cell here, if you want to work in Python, you will see a statement called import pandas as PD. So what this is telling us in Python is that you can import some packages. There are some packages that some people have already done to make life easier for you when you are coding in Python, so that you don't have to do it from scratch. Like if you want to read your data file, for example, you would use pandas. So you don't need to start writing a new code on how to read your data file. Pandas will do that for you, right? So if you want to run these pandas, let's just go step by step on all these things here. So these are called, let me call it packages. So there are different packages that we use in Python, and we import them. Packages are imported. Import packages. Import, maybe let's say you can use general syntax in Python for importing is import package, simple. But if you want to shorten the name, you can add this as. This is optional, but you can use it. So anything you want to import, you can just use import the package name. Your package name like this. So this package now is called pandas. Pandas is for pandas. I'm putting hash here because I'm making it a comment. So you can use hash to write comments in Python. So pandas is for data manipulation. Pandas is used for data manipulation. So the thing you can do now, you can use Shift Enter, but for phone, you can just press play. So it will run this cell for you. Just press play and it will import it. Okay. Now, there are some packages that may not already be in Python, like pandas. You may need to install that. So we'll talk about installation as time goes. But let's just focus on import package name. You run it, that is it. Then now, we want to now start, the first thing you need to understand in Python are variables. So Python is really easy, that it's as simple to declare a variable. It's as easy as just assigning the value to it. So we're saying x is equal to 2, y is equal to 5. On to the other part here. I don't like this xy. Okay, let's do it like that. Okay, x is equal to 2, y is equal to 5, and it says xy is equal to a big data class, or let's say a 3 MTT, whatever, 3 MTT, let's say Nigeria, 3 MTT Nigeria, right? So it means that anytime Python sees x, it will know that it's 2. Anytime it sees y, it will know that it's 5. Anytime it sees xy, it knows that it's this. Then you can add another variable here if you like. Let's say we use big Y, because we can use big Y because Python, if you use small x, you always have to call it with small x, right? If you use small y, you always have to call it with small y. So Python is case sensitive. Python variables are case sensitive. So let's say y is equal to 10. So if you run that, nothing would come out now. There's nothing that will come out when you press play, but you've already assigned values to all of this. You've already assigned variables, values to these variables, right?
Victor, don't comment.
Okay, you already assigned values to these variables. Okay, so but if you want to print something on the, if you want to print something out on your notebook, right? You can use print statement, print bracket this, but I don't like this. You can check your notebook if you can see where to press code. If you press this code up there, right? Or you just, I think if you click out and press A. If you click out here and press A, you can get a new cell on top of it. A. Or if you just check your notebook there, see if you can see this button here, you press code on top of that. So you see a code. Then if I say print bracket X, and you run it, it's going to print the value of X, because Python is now going to see X as 2, Y as 5, then big Y as 10, or XY as this. So let's also print XY. Let's see what it will do. Print XY. Print bracket XY, then you press play again. Python is printing, hey, 3MTT Nigeria. So anytime Python sees this variable, because you have assigned this variable a value, anytime Python sees it, it's going to use that value. So let's create another cell above code. Let's say print small y plus big Y. Small y plus big Y, you play that, it's going to add. Okay, let me pause here. Let's see if we're following. Wait. Now, any questions so far? Are you following? Let me pause here. I want to ask a question. Are you following?
Yes, I'm following.
Okay, so the question now would be, if we print small y plus big Y, what do you think Python will print out here?
I think it should be 15.
To print out 5 and 10.
Yeah, so to print out 5 plus 10, yeah, which is 15. So print out 15. So it's going to add y plus y here, which is 5 plus 10, right?
Yes.
So I've gotten now into, I've done simple assigning a variable a value, just simple assignment. Then we've seen how to use those variable print it. Then we already started a maths, an operator, which is using addition. So Python has different operators here. If you go down in the notebook, you can see addition, just simple addition, subtraction, division, everything, right? There are other ones here that you may not use too frequently, but it's good to know them. So addition here, just play this cell, 1 plus 2 gives 3. Play this cell, 2 minus 1 gives 1. 1 times 1 gives 2. 1 divided by 2, 0.5. 1 divided by 2.0, the same thing. But this one is a mode. Let's see it here, 15 mode 10. So mode would give the remainder when you divide a value, but you may not use it much. So 15 mode 10, this percentage, 15 mode 10 would give you 10 into 15 would be 1, remaining 5. So remaining 5. But you don't need to bother much about this. This is floor division. This will give the main value, which is 1. Like if we do, let's do 15. Let me check 15 more. What do you call it now? This floor division, 15 division, double division, floor division 10. That would give 1. So this gives the main value, why this gives the remainder. But you don't have to bother much about that for now.
We can do all this on Visual Studio.
Yes, you can do it on Visual Studio. So for Visual Studio, if you go to your Visual Studio, you have to go to the folder where you have that that notebook. Then you open the notebook. So on Visual Studio, you have to go to the folder where you have that notebook, and then you click on that notebook. Yeah. But I can't open my Visual Studio now. Yeah. Yeah, I think this will be easier for everyone to follow. Maybe next time, if we want to do Visual Studio, we'll explain that for everyone else. Yeah. Okay. So let's use Colab for now. Yeah, but you can do this on Visual Studio. Just go to the folder where you have the notebook and then click on it. It's just the same thing that we're doing here right now. Okay, so the remaining relational operators, you can see here, it's true if it is equal. So if you put z equal 1, you're trying to check, this statement just means is z equal to 1? is Z equal to 1. That's what this is. So if you assign a value to Z, let's say we assign 1 to it, then you check, is Z equal to 1? If you say true, because this equal to double symbols here usually is a they call it a true statement. You are comparing. You are trying to compare if this value is actually true or false, right? Then if you check now, this one is Z greater than 1. It says false, right? Let's check. Is Z equal to 5? Z equal to 5 says false because Z is equal to what? 1. Let's check, is Z less than or equal to 5? It says true because Z is 1 and 1 is less than or equal to 5. So these are just basic programming that you can do. Because why this is important, we're going to use it, for example, sometimes to test conditions, to test. So for example, you say, oh, if the output of the model is a cat, then do this. If the output of the model is a rat, then do this. So those are different things that you can do using such tests. Okay. Any questions so far? Are you able to run it on your phone? Yeah, are you able to run it on your phone? Yeah.
Mine is not a question. Mine is not a question. It's more like a suggestion. Some of us were thrown out because of network. Please, can you resend all the links again? Either to the
Which link? Okay. Oh wow. Wow, a lot of people left before. Huh. Which of the link? Okay, the Google Colab. Which one? This one? This one? Is it this one or which one?
Sorry, sir. I had a network glitch. I didn't get that.
Okay, is it this link of Colab? Yeah, that's the only link I've shared. The other one, it's on WhatsApp. The notebook is on WhatsApp. Okay, so we're going to be rounding up soon. So yeah,
Sir,
please go ahead.
So I
sorry
hope this is recorded so we can view it later.
Yes, it's recorded. So I think
Thank you.
Yeah, I think we're going to be running up.
Hello, sir. Sorry for dragging us back. I was thrown out again. So I didn't even get your response.
Now, I was saying that if it's Colab, I've already sent the Colab link on the chat. And then you can also go to WhatsApp to see the notebook on WhatsApp.
Okay, it's exactly what I meant. The Colab link.
Yes, I've sent it. Because it's this one, colab.research.google. I just sent it now again. So let's wrap up here. Maybe we'll do more Python next class. But what I want you to do is this assignment is just go through this notebook. I've sent it on the WhatsApp group. Go through the notebook and run it. Just run. Usually you have to run one cell before the next. Just read it and run it. It won't take you up to 2 hours. Just find time to go through so you can get familiar with Python. Try to run it this week. Try to run this week. Just go through it. You understand data structures.
Sir, please remember to post the assignment. Thank you.
Yes. So I'm going to paste the assignment. Then one thing now. Which would you prefer? Let's do it like, which would you prefer? Should I place people on groups, or do you want to select groups yourself? For if there are people you want to work with, you just group yourself, or you can post your group on the post your group.
I don't think my name is even on this group. I tried to edit that time. I wasn't able to. I don't know.
Okay, no problem. So sorry. About rounding up, please. Just hold on, please, while about rounding up so that I can get the final things I'm about to say. So One is 30 minutes. Okay. So one is you are going to select your groups this week. So select your groups. Select your group for the project. So I wanted to select the group for you guys, but I feel like some of you may have people that you want to work with just to ensure the group is effective. We want about, let's say, I don't want the groups to be more than 10. If there are 70 people in the class, let's say 7 people per group. So maximum of 7 people per group will be working on a project, right? So select your group this week. So some of you can give your group any name. Oh, the intelligent group.
Can you divide us?
Okay, let me divide it. Hey,
yes, I think you should be
Yes,
the one
sir.
to do that, please.
Okay, let me divide it. Okay, there was one course I took one time. So what they just did is everyone would just oh, I'm looking for people on my intelligent group. People would join or my star group. So that was interesting to see. But yeah, I can divide, but you have to put your name on this list. So if your name is not on this list, please. I've already started dividing it actually. So we have 37 people on this group now. So please add your name to the group. If you say you can't do that, maybe I'll
drop it now? Can you drop it now so that some of us, because I tried the first time, I was not able to edit it.
Yeah, it's I think it's editable now. Okay, so please edit this take. Okay, that's one. Then secondly, so if you once you select your group, then we're going to post some projects that you can select from within next week. I'll post the project for you to select from. Then you're going to go to, I'll share this link with you guys also on WhatsApp. So you're going to go to Calendly. Then there are group slots. There are slots for mentorship. So I want to have some one-on-one meetings with each of those groups. So as we are working on your project, we'll meet one-on-one either on Saturday, on Wednesday, or Friday. The time slot is between 8 p.m. to 10 p.m. Nigerian time, but it's usually for 45 minutes. So we're going to meet bi-weekly, at least once in 2 weeks, to monitor your project. Once in 2 weeks, so we may have like 5 or 4 meetings within the period of this program. So when we meet, then we can understand how everybody is doing, understand how you are learning, and see how we can help you support your project development, right? So Saturday, Wednesday, or Friday. So when I'll share the link with you. When you go for Wednesday slot, you will see the time to pick here. It said 10 spots left, but it's one spot. I'm just assuming there will be 10 people in a group or 7 people, but we're doing 7 people marked per group. So I'll probably change this. But book your time from, I think from next week. From next week, we should start meeting for the project. So your assignments, I'll share with you. Go through this notebook and then also go through the link I will share with you. And then we'll share your project within next week. Okay, that's it. That's all for this class.
Yeah, please, I have a request.
Okay, go ahead,
Yeah,
please.
if you can help us open a OneDrive folder and then each class will be arranged. Maybe today, the video, the materials will be put in a folder within that OneDrive folder, and then subsequent meetings too. So we can have a single link to all the resources that you're going to be sharing with us.
Yes. So I'll do that. I think Afrilearn will also be supporting with that. So yeah, Afrilearn will also support the recording uploaded on YouTube. Yeah. So we'll have that for sure.
Thank you.
Okay. Yeah. All right. So I want everybody to go about their day now, while we wrap up here. Okay. Look at that. Where the collab link is. This one. Oh shit! This is. Okay. So I'll stop the recording now.